Hello, today we study product and quotient rules. The product rule says if you have two functions f and g and both are differentiable, then the derivative of their product f times g is equal to product of the derivative of f times g plus product of f times g prime. So basically, if you look at this formula, right, you have derivative right here, and then since you have two functions in the product, at the end you have two terms. In the first term, you take derivative of f times g, and then in the second term, you take derivative of g times f. And sometimes I say, yeah, we just move this symbol, right, to the f and then to the g. You see this? So by that logic, if you have three functions, you do almost the same thing. Let's write it down, okay? So I write in short f times g times h derivative. So I have f derivative gh plus fg derivative h plus fg h derivative. You see, that's how product rule works. Okay, let's consider the following example. Suppose that you have y equal to 3x minus 2x squared times 4x minus 5. And you want to find the derivative of this function. Of course, you can, for this out, right? You distribute it, and then you write this as, sum of different single terms, and you differentiate each term because, you have some polynomial, right? Polynomial. But we don't have to do that. We can use the product because in this case, you have product of two functions. This is the first one, this is the second. And you can write, yeah, this is f, this is g, right? So the derivative right here is just equal to f derivative g plus fg derivative. I try to rewrite the formula all the time because, sometimes I see that students use the following product rule, right? Which is not, of course, product rule. That is wrong rule. They write f g derivative equal to f derivative g derivative. Of course, this is wrong. Okay, so try to avoid that. How? Please have a formula sheet for yourself. Okay, and then you copy all formulas you need each time. If you don't remember, please check that. Okay, so I very recommend you to write the rule before you apply it. And now I have to find the derivative of f and the derivative of g. That's it, and write them all together. So I can write separately f derivative is 3x minus 2x squared derivative. I have 3x derivative minus 2x squared derivative. Right? So that is 3x derivative minus 2 times x squared derivative. If you are already familiar to differentiation rule, so you don't have to write that. You can write this is 3 and then minus 2 times 2x right away, right? You can skip this step, but I just try to make everything clear. And this is equal to 3 minus 4x. Okay, don't forget the derivative of x is just 1, so I don't write it. And then you can find the derivative of g. G is 4x minus 5, right? 4x minus 5 derivative. And we know derivative of 5 is 0, so you have derivative of 4x minus 5 derivative, which is 4 minus 0, and that is 4. So you have all f derivative and g derivative. From now, I can write the y derivative is 3 minus 4x, which is f derivative times g, 4x minus 5, and then plus g f. So I write 3x minus 2x squared. I try to keep the order fg, okay, times 4. You might simplify this, but if they just ask you to find the derivative of some function, you don't have to simplify it, okay? All right, so that's how we can apply the product rule. Now let's move to the quotient rule. The quotient rule says if you have some function f of x equal to p of x over q of x, and you want to find the derivative of this function, then that is p derivative x times qx minus px times q derivative of x divided by qx squared. You know, this is very simple consequence of the product rule. Why? Because this is nothing but px times q to negative 1x. You see that? And if you use the product rule for this, so probably you see the right way, right? But anyway, you have quotient rule in here. Here's the difference between the product rule and the quotient rule. On the top, you still see p derivative q, p q derivative, but the sign here is negative, right? You see? So, and here you have px squared, okay? Let's apply the quotient rule to find the derivative of the following function. Phi y prime for y equal to 3x squared minus 1 over x plus 1, right? So basically the px is 3x squared minus 1 and the qx is x plus 1. Then before we write the answer, I think we need to differentiate p and q, right? So I can write that separately. P prime is 3x squared minus 1 prime. Now I don't write 1 prime because that is 0. So I have 3x squared prime, which is 6x. Okay. And then qx prime is x plus 1 prime, which is 1, right? Then from here, I have y prime equal to p prime, which is 6x, times q, which is x plus 1, minus px is 3x squared minus 1 times q prime, which is 1. You see? And then divide by q squared. That is x plus 1 squared. Again, if they don't ask you to simplify, you don't have to. Okay? So that is about the quotient rule and the product rule. Now, let's consider the following tangent line problem. We have function f of x equal to 3 minus 1 over x divided by x plus 5. And they ask us to find the equation of the tangent line to the graph at -1 and 1. So they give us the x and the y. We don't have to find the y0, right? So basically, we need to find the slope, which is the derivative of this function at x equal to -1. So we need to find the derivative f prime. In this case, we need to use the quotient rule, right? So by the quotient rule I have, that is 3 minus 1 over x derivative times x plus 5. That is f derivative g or pq minus 3 minus 1 over x times x plus 5 derivative divided by x plus 5 square. You see? So the derivative of 3 is 0 and the derivative of 1 over x is, let me remind you that, right? 1 over x derivative is -1 over x squared. So we have negative in here. With the negative, you have plus, right? Yeah, plus. So I have 1 over x squared in here times x plus 5. We can simplify later. And then minus 3 minus 1 over x. Derivative of x plus 5 is 1 because x derivative is 1, 5 derivative is 0. So I just write 1 in here and divide by x plus 5 square. You know, you don't have to simplify, okay? Because they don't ask you, right? And we need to find the slope. From here, I just plug the point -1 into the formula of the derivative. So the slope is equal to f derivative at -1, and I just plug -1 into this expression. I have 1 over -1 square times -1 plus 5 minus 3 minus 1 over -1, right? In here I have -1 plus 5 square. You see, I don't have to simplify, right? And now I just, yeah, and now of course we might simplify, but I mean, we don't need to simplify the derivative, okay? So I have this term is just 1. Here I have I have 4, right? And here I have 3 minus plus 1, which is 4, right? So the slope is 4 minus 4 over 4 square, which is 0. Then the equation looks like y minus y0 equal to 0 times x minus x0, or y equal to 1 because y0 is 1. Interesting, right? But what does it mean? The slope is equal to 0. How do you think? We have slope in here, and that is 0. The slope is 0 means the derivative is 0, of course. And not only that, the slope is the tangent of the alpha, where alpha is the angle between the tangent line with the x-axis. Is that correct? But the slope is 0. That means the alpha is 0. Is that right? The alpha is 0. That means the tangent line is horizontal. You see, that is interesting, right? So that means in case if they ask you to find Rx such that the tangent line is horizontal, so that means you have to find the derivative and set it equal to 0. Agree? The reason for that is when the tangent line is horizontal, you might be in one of the following situations. You might be like this, right? Or like this. You see? So in this situation, you might think like, yeah, this point is the highest point, right? Is the highest point. Is that correct? And this guy is, is the lowest. Is the lowest. So in some sense, this is the maximum, right? And this is the minimum. So you see, that is interesting, right? So that means, this problem, the problem to find x such that the tangent line is horizontal, is equivalent to the problem that just partially, okay, I just mentioned partially, right? I write here partially, equivalent to the problem to find points where the function may attain maximum or minimum. Does that make sense? So you see, we already see some applications, right, of the tangent line problem. You see that? All right, so I think we are good with the quotient and the product rule, given that we solved just a couple of problems. But I hope you practice more and more on website or from the textbook, okay? That is the only way to understand how we can apply differentiation rules for tangent line problem. And in the next chapter, we will study applications of differentiations, so we need more differentiation rules. And now I would like to move to the higher order derivatives. Look at this. You have a function, right? Let's say y equal to 3x cubed minus 2x squared plus 1, for example. You want to find the derivative. So you have 9x squared minus 4x, right? And you see that the derivative is a function, right? That is a function. And in this case, you have polynomial, right? And you see that you still can differentiate this function. You get y2 prime is 18x minus 4. So what is y2 prime? What is y2 prime? We know that the derivative is the rate of change, right? Is the rate of change. So at the same time, that is velocity. Is that correct? So what does mean derivative of the derivative? Okay, so we have derivative of, let's say, velocity. So what's that? That is the rate of change of the velocity. Rate of change of the velocity. Right? And of course, this is the what? The acceleration. Does that make sense? So you see, the first and the second derivative have some practical meanings, right? The derivative is the velocity, or that is the rate of change. And the derivative of the derivative is the rate of change of the velocity. So this derivative is called the derivative of the other two, or that is the second derivative. And if you can differentiate the function in the third term, in the fourth term, or in general in the nth term, right? So you have nth derivative. Does that make sense? So let me summarize that before we move to an example. So I have function f, y equal to f of x. So if you can find y prime equal to f prime, that is the first derivative. Second derivative, right? That is the derivative of the first derivative. Okay, let me write this form. The derivative of the first derivative, right? That is the second derivative. And so on. You might have the nth derivative, which is derivative of the order n minus 1, right? And derivative. Okay, so all these are higher order derivatives. Let's consider the following example, and then we finish today's video. I have function st equal to negative 0.81 t squared plus 2. I hope you still remember the rate of change problem, right? We might use that model. Let's say you have some object. That object is falling down, right? When t is equal to 0, you have the highest height is 2, right? S0 is 2. Okay. So I remember we and suppose that the position of that object is described by the function st. Okay. So using this function, we may find the velocity or the instantaneous velocity. Okay, so the velocity is equal to s prime, which is equal to negative 0.81 times 2t, right? Because the derivative of t squared is 2t. So you have negative 1.6 That is the velocity. And if you differentiate the velocity, you get the acceleration. Okay, so here you get the acceleration. That means the rate of change of the velocity. So you have negative 1.61. Okay. In order to finish this video, I would like to ask you one question regarding the velocity and acceleration. So how do you think? Which measurement is more important in sport? Okay, I write here. Which value is more important in sport? It says, yeah, suppose that you are a sportsman, right? And people are talking about the velocity of your movement and the acceleration of your movement. So which one is more important? Okay, let's think about that. All right. Thank you for watching. And if you have any question, please feel free to let me know.